Greetings, everybody. My name is Kartik Tyagi. This is Ayushi Singh. This is Rashiv Verma, and that is Subrat Ranjan. We are from Maharaja Surajmal Institute of Technology, which comes under the GGS IPU University. So we joined Fine Academy in our second year, and we learned a lot of basic about VLSI and our core branch, that is digital electronics, FPGA, VGA, a lot of practical things that we learned about in our second year. After our training completion, we got a project from our industrial partner, Forges Technologies, and the engineers they guided us. It was a really simple project, and the project involved a four-way traffic light management, and it included the usage of Verilog hardware description language, which is a very common language used in the EC core branch. Now let's start with the presentation. So first of all, the objective of our project is to design a real-time traffic light controller for a four-way intersection. So this project will be a real-time project. That is, it will be having its values changed according to real time, and they're not hard coded. The second is to display directional timers and signal states on a VGA monitor. This means that every direction, north, south, east, west, all the four directions will have each of its timer, that is four timers in total, and it will have signal states drawn as circular lights, and they will be on and off, by which we will be knowing the state of the traffic. Then the third one is to implement using Verilog HCL, as we discussed, and deploy it on an FPGA board. Moving on, this is the basic prototype of our project, and it will look like this. Every direction has three lights: red, yellow, and green, and each one has its own time. This is north, south, east, and west, the convention directions. Now, as we hit start on our FPGA board, the first thing that we'll see is the timer here is set to 20. It's 25. South one is 50, and the west one is 75. And the first one that starts from north, it is green. And the green, and we'll be moving in a clockwise direction. That is from north to east to south to west. After that, after 20 seconds of completion, we'll see that here it is 0 and it is 5. Now what happens is it transitions to yellow light. Now yellow light will be on in north for 5 seconds. After that, after 5 seconds have passed, we will see that here it is 0 and each one is also 0. Now we will see that it comes the turn for the east direction. So the east direction will have green light. Now this circular loop will continue for as long as we want. Now the system overview, I'll just explain in really brief. It is a four-direction traffic management, that is all these directions. Then there's visual countdown timers, as we saw. These are the timers. After that, graphical signal display on VGA, that is our lights. These are our signals. Then FSM-based control synchronized with 1 Hz clock. FSM, my fellow teammate will be explaining what it is. It stands for Finite State Machine, and it is a major part of our project on which all our project is dependent on. It works on a 1 Hz clock. There is a 25 megahertz clock used for VGA rendering, which is the basic rule of VGA rendering. It works on a 25 megahertz clock. Now I would like to call Subrat and give him the floor to explain the further details of our project.
So our topic is VGA. Video graphic array uses analog signal to transmit the video data from the computer to the monitor. These signals usually continuous in nature, and usually supports a wide range of resolutions for 640 into 480p, and we are also using in our project. And secondly is so it uses 15 pin connector, generally also called as a VJ connector, and uh, D, uh, D sub connector, like it is D sub structured. And then it also supports a color depth of 16 colors initially, and further later it will increase by 256 colors. And then it also helps to display and image in a screen to to generate some real-time data, and also it used in it used to generate vertical and horizontal synchronized signals. So this is our VJ port in on FPGA board. So if we talk about VJ display design, so our resolution is 640 into 480 that we are using in our project, and color depth is 4-bit red, green, blue. And if we talk about like each of the color signals, like VJ green, VJ blue, and VJ red, so all are in 4-bit, uh, 4-bit. And also additionally we use FSIC for horizontal sides and VSIC for vertical sides. It persists to maintain the VGA standard. So this is our VGA display breakdown. Initially, like we talk about the full resolution is 480 and 640p. So we divided the first rectangular part at all the corners is 170 into 250 way, and the remaining parts is called we consider as road. And then to display the circles for in VGA, so we have to use the mathematical formula that is dx square plus dy square is less than and equal to r square, where r is the radius of the circle, and we took r equal to 12 centimeter. Yeah, basically it efficient pixel by pixel computation, and this is also color logic based on traffic state in all purpose. And so firstly, we draw a centroid of each circle, like north at top, south at bottom, east at on right, and west on left. And then for every pixel that is the part of a circle, if we consider as if it states green, then it will time for 20 seconds, and then it will yellow seconds for 5. And if the circle in rest mode, then it will show the red color. So yeah, and then our then Ayushi will come to Ayushi will explain the further slide.
Okay, for further explanation, I would like to explain you all the Verilog coding modules used in our project. Basically, we use 5 major modules. The first one is clock division module. This clock division module was used so that we could synchronize the clocks, which can work according to the VGA display and also according to our FSM logic. So for VGA display, it majorly works on 25 megahertz clock. So to convert the 100 megahertz clock of the FPGA, we implemented a counter which counted to adjust the clock to 25 megahertz. And for FSM implementation, we had to modify the clock to 1 hertz, which could count the seconds. So for the counting of the seconds in 1 hertz, we again implemented another counter so that it could work according to our needs. Now, for the second module, we used VGA display. Basically, where we design all the our structure where all the circles will be placed and how our system will look like. It is designed to look like a standard traffic light crossroad, which display 4 roads and all the red light and green light and yellow light on each of the sides. Now, for most important module is our FSM control module, which is basically a Verilog hard structure. It is hard coded to change the state transition from one state to another. Basically, we majorly used 8 states, which will transition from green to red to yellow on each of the directions. Now, time control module. This module was designed to implement the counters, which will count on each of the sides. Basically, 4 counters on for each of the sides, where they will show the countdown and how much time is remaining for the next light to implement. Now, the most important is VGA and FSM integration module. Since we have already designed the circuit and how it will look like, and also we have designed the backend on how it will work. Now, our main motive was to integrate both and see how it will work further. Now, as you can see, this is the clock division logic where the input clock is basically 100 megahertz. So we divided it into 1 hertz and 25 megahertz. This 25 megahertz work for the VGA controller and 1 hertz clock is simultaneous to 1 second, which will act as our FSM logic. Now, as you can see, to use 1 bit counter, we used 1 bit counter for 25 megahertz and 26-bit counter for 1 hertz, which will serve as the FSM logic backend. Now, the FSM design for the control logic system. This is the code snippet where you can see S0. S0 is our initial state, which will show the north light as green. Here you can see TLN is for the north side of the road. It is hard coded to show green, and other are hard coded to show red. As you can see, a finite state machine is a logic system. Basically, FSM is a state logic system which is typically used in digital logic design, but which serve as a base of VLSI and other electronics, where we use to predict our next state based on our present or past inputs. We have typically used Moore machine, where we will be going to the transitioning to the next state based on our current state. For example, if we are at red, then our next state will be yellow or green as per our needs. Okay, so in our transition logic, in our code, we have used start as an active button. If we switch to start, the system light will continue and it will go on in loop. The timer done is set to 1. Basically, timer done is a register used in our code which is set to 1, and if it is set to 1, then our timer will stop and it will transition to the next logic. And if we are at red, then we will transition to yellow and further on. Now, timer and counter logic. Basically, this green time and yellow time are our major counters. Green time is set to 20 and yellow time is set to 5. And we will be alternatively using it in our code further, where we will set the green light to glow for 20 seconds and then transition to yellow or red light based on our next state transition. Timer done is another register signal which is used to showcase if we are ready to move on next state or not. If the timer limit and timer done are equal, then we will transition to next state. Otherwise, we will continue on the loop. Countdown displayed on the VGA screen. Another thing of our project is we can see the countdowns displayed on the VGA screen. As you can see, there are 00 for green. It means now the next state will transition. And also there are other counters on other sides which will show how much time is left for other green signal to appear. As there are 5 seconds, so in 5 seconds there will be green signal on each side, and further on as we move on other side of south or west. Now, for our next slide, we will see how the FSM is integrated with the VGA, where FSM is the backend of our project, which works on 1 Hz clock, and VGA is our front end, which works on 25 megahertz clock. And we will see how the FSM is integrated into VGA to show how it will work according to the timer. So, from the FSM, we get an output, which is basically the signal on which color or which direction will work as on state 1, and which color and direction will work on state 2. And then FSM gives the output. It goes as input into the VGA module, which we have earlier discussed. And also there is timer values, which is basically the 1 second clock, which works as a counter and it counts downward. Okay, so though both of the output and input combined, they give us FSM plus VGA, which we can see on further demonstrations. Basically, everything is synchronized by 1 Hz and 25 megahertz clock. Now, for the applications of our project, our project is in its initial stage, but for and on further development, we can see more applications of it. For example, intelligent traffic light control system, FPGA learning projects, real-time embedded display demos, educational lab in digital design. On further adjustment, we could implement these using AIs and other things to make students learn on the basics of BGA, FPGA, Verilog, and basics of VLSI. Future scopes. Basically, since this is at beginning level, we can add further adjustments such as integrate AI and sensors to make it more viable and more applications of these future scopes. For example, we can add pedestrian crossing logic, integrate real-time vehicle sensors. which can control if there are more traffics on a particular direction, then we can control using it remote or Wi-Fi, and then we can adjust the timers of that direction. Dynamic signal timing using AI, which is similar to traffic sensors. Basically, we can use it controlling AI and we don't have to monitor it all the time. Conclusions of this project. So in the end, if we are going to conclude the project, then we can say that we worked on FSM and VGA and FPGA using Verilog hardware description language. We have successfully implemented traffic light FSM with VGA output, as you have seen in our presentation. Modular architecture using FSM, timers, counters, and VGA interface. And this is also a real-time project, as you can see the counters counting downwards in all the directions and not just in one direction. It is in dynamic mode, and we have not hard-coded it to just static. So in the end, I would like to conclude that we have learned a lot from this project, and we would like to learn further from our mentors. Thank you. Okay, for further demonstration and live demonstration of our project, I would like to call my fellow member, Rashiv. He will show you how our project is working and how it is looking on the VGA display. Rashiv, please.
थैंक यू आयुषी। अब मैं आपको बताऊंगा कि ये तो हमने इस पर काम वगैरह कैसे करा है। मेन हमने विवाडो को यूज करा है और वेरिलॉग हमने कोडिंग लैंग्वेज यूज करी है। ये हमारा पूरा होल कोड था। इसमें हमने क्या कहते हैं वीजे का एक अलग मॉड्यूल बनाया है, फॉन्ट का एक अलग बनाया है और क्या कहते हैं एफएसएम का एक अलग मॉड्यूल बनाया है। इसके बाद ये हमारा पूरा प्रॉपर सिमुलेशन करने के बाद हमारे जो रिजल्ट आ रहे हैं वो ये सब हैं। नेक्स्ट, और ये हमारा पूरा का पूरा प्रॉपर डिजाइन है कि हमारा वर्किंग कहाँ से और कहाँ तक जा रही है। ये आप ऐसे देख सकते हैं कि कहते हैं कि कौन से पॉइंट से कौन से कहाँ से कनेक्शन वगैरह हो रखे हैं। और लास्ट में हमारा आउटपुट वीजी के थ्रू क्या कहते हैं कलर डिस्प्ले के और क्या कहते हैं अलग अलग कोऑर्डिनेट्स पे आ रहे हैं। अब मैं आपको बताता हूँ क्या कहते हैं ये नाउ। अब मैं आपको बताऊंगा कि हमने इसमें से कनेक्शंस वगैरह कैसे कर रखे हैं। ये आप देखोगे तो ये हमारा एक वीजे केबल है, इसको मैंने अपने मॉनिटर के थ्रू कनेक्शंस कर रखे हैं ताकि हम डिस्प्ले वगैरह उसमें करें। ये वायर क्या कहते हैं मैंने अपने लैपटॉप के अंदर कनेक्ट कर रखी है, तो क्योंकि कोड वगैरह अगर इंप्लीमेंट करना है तो हमने बेसिस का यूज करा है। और इसमें अगर आप मैं इसमें स्टार्ट बटन स्टार्ट करता हूँ तो आप देखोगे सबसे पहले कि हमारी रेड नॉर्थ की ग्रीन लाइट हुई है। अब 20 सेकंड बाद क्या होगा, इसमें क्या कहते हैं येलो लाइट जलेगी 5 सेकंड के लिए, और नॉर्थ की और ईस्ट दोनों की। फिर अब क्या कहते हैं ईस्ट की हमारी ग्रीन लाइट काफी जल रही है। इसमें यह है क्या कहते हैं मैं इसको पूरा का पूरा पॉज वगैरह भी कर सकता हूँ अगर मैं स्टार्ट को दोबारा से दबाता हूँ और सारा का सारा फिर ये। और मेन हमारे पास है कि रीसेट। रीसेट से क्या होगा पूरा का पूरा एक तो ब्लैंक हो जाएगा, और अगर मैं इसको रीसेट को 0 दे देता हूँ तो वो दोबारा से स्टार्टिंग हो जाएगा। चलो ठीक। अब स्टार्ट बटन दबाने के बाद क्या कहते हैं हमारे क्या कहते हैं नॉर्थ की लाइट 20 सेकंड के लिए जलेगी। उसके बाद क्या होगा नॉर्थ और ईस्ट दोनों की हमारी 5 सेकंड के लिए चलेगी, और फिर ऐसे ये पूरी की पूरी साइकिल लूप में एक तरीके से चलती रहती है। एक बार में ये हो जाए। अच्छा, अब नॉर्थ और ईस्ट दोनों की 5 सेकंड के लिए चल रही है, और चेंज हो गया क्या कहते हैं ईस्ट की ग्रीन लाइट 20 सेकंड के लिए चल रही है। ईस्ट और साउथ दोनों की हमारी 5 सेकंड के लिए येलो चल रही है। अब ऐसे ही पूरी की पूरी साइकिल क्या कहते हैं जब तक हम इसको स्टार्ट या फिर रीसेट वगैरह में से कोई भी प्रेस नहीं करते हैं बटन, तो क्या कहता है हमारा पूरा का ये पूरा लूप के अंदर चलता रहेगा। तो ये हमारा पूरा का पूरा होल ये हमारा पूरा का पूरा होल डेमो है। थैंक यू एवरीवन।